You know those moments in a detective story where um, a tiny detail everyone missed just cracks the whole case wide open?
Yeah, absolutely.
Well, today we're diving into something like that, but in the world of gems. It's a bit of a geological whodunit, really.
And the twist is amazing. The discovery happens after the gem is already cut and polished. We're talking about Taffeiite.
Exactly. Taffeiite, the only gemstone first spotted, ready to be set in jewelry.
It's pretty wild to think this incredibly rare gem was just hiding in plain sight for who knows how long, likely mistaken for something else entirely.
So for this deep dive, our main source is the Wikipedia page on Taffeiite. It's surprisingly detailed for such a rare stone.
It really is. And our mission, yours and mine, is basically to unpack what makes Taffeiite so special.
Right. It's discovery, what it's actually like, why it's so rare, but without making everyone feel like they're back in a geology lecture.
Let's keep it engaging. Sound good.
Perfect. So let's picture this. It's October 1945, Dublin, Ireland. There's this gem enthusiast, Richard Taaffe, and yes, that's Taaffe, the namesake. He buys a batch of cut stones from a jeweler.
Believing they were spinels, right? Which is a common enough gem.
Exactly. But Taaffe had a really sharp eye. He looked closely and thought, one of these things is not like the others. Something felt off about one particular stone.
And that's the key, isn't it? That keen observation. He wasn't just collecting, he was looking. Really looking.
Totally. So this nagging feeling leads him, on November 1st, 1945, to send these stones off for analysis.
To B.W. Anderson, over at the laboratory of the London Chamber of Commerce, a well-respected gemologist.
And the reply comes back super fast, like November 5th, just 4 days later.
But it wasn't a simple confirmation. Anderson writes back, and he's not entirely sure what he's looking at.
Uncertainty. The plot thickens. He basically says, could be spinel, could be something new, and he even suggests writing about it in Gemologist magazine.
Imagine getting that letter. It must have been thrilling, but it also points to how easily Taffeiite was overlooked.
Yeah, that misidentification of spinel is a huge part of the story. For ages, it seems people just assumed it was spinel.
Which is understandable, apparently. The Wikipedia source mentions they have some identical structural features, so visually, especially once cut, they could look very similar.
Practically twins. But there was one crucial difference. The smoking gun, if you will.
Ah, the double refraction.
Yes, explain that. Spinel is singly refractive.
Right. Light goes in, travels along one path, comes out simple, like looking through regular glass.
But Taffeiite.
Taffeiite is doubly refractive. When light enters the crystal, it splits into two separate rays. That optical effect is a dead giveaway.
That was the aha moment, the sign that this wasn't just another spinel.
Precisely. It's a fundamental optical property, a fingerprint for the mineral. So, okay, fast forward a bit to 1951.
What happened then? More tests?
Yep. Proper chemical and X-ray analysis, and this is where they nailed down its main ingredients: beryllium, magnesium, and aluminium.
And here's a fact that it floored me when I read it. Taffeiite was the very first mineral ever found that contains both beryllium and magnesium as essential components in its structure.
That's a pretty cool distinction, isn't it? Chemically unique in that specific way.
Definitely. So let's get into the nitty-gritty of its properties, the chemical formula.
Is BEMJL 408, though since 2002 the official mineralogical name is a bit of a mouthful. Magnesiotaffate 2N2S.
Magnesiotaffate. Okay, yeah, let's maybe stick with Taffeiite for now. That long name probably reflects a more detailed understanding of its crystal structure, I guess.
Exactly. Science marches on, refining the classifications. But yeah, Taffeiite works fine.
And colors. If you were lucky enough to see one, what might it look like?
The palette is actually quite subtle and lovely. Things like colorless, grayish, violet, violet red, actual red, greenish tones, light green, pink, violet, mauve. Nice range.
Sounds beautiful. And how does it form? Like crystal shapes?
Typically, it forms prismatic crystals, sort of elongated column-like, or very commonly as alluvial grains.
Alluvial, meaning found in riverbeds and streams, washed down from somewhere else.
That's the one. Like panning for gold, but much, much rarer. The source also mentions it can be twinned, where crystals grow interlocked in a symmetrical way.
Interesting. What about how it breaks? Does it split cleanly?
Not really. Cleavage, that tendency to split along flat planes, is described as imperfect to fair, sometimes even absent.
So it doesn't just snap neatly.
No. Instead, it tends to have what's called a conchoidal fracture. Think of the curved, shell-like way glass breaks.
Okay, got it. But it's hard, right? I remember reading that.
Oh, yeah. It scores an 8 to 8.5 on the Mohs hardness scale.
Wow, it's pretty tough. up there with, what, topaz, spinel itself?
Exactly. Very durable, which explains why the first one found was already cut and polished. It can handle the process.
Makes sense. What else? Shine, transparency.
It has a vitreous luster that means glassy. Its
Yeah.
streak, the powder color, is white. And it can range from fully transparent to just translucent, where light gets through, but it's a bit diffused.
Now, okay, things might get a touch technical here with the optics, but they seem important for identification.
They are crucial for gemologists. It's described as uniaxial. That relates to how light behaves inside the crystal along a specific axis.
And it has specific numbers associated with how it bends light, refractive indices.
Right. No 1.722 and no ixley equals 1.777. Those precise values help distinguish it. The difference between them, the birefringence, is 0.055.
Okay, and I saw something about pleochroism.
Weak cleochroism, yes, which means if you turn the stone and look at it from different directions, you might see very slight changes in color. It's subtle.
And density, specific gravity.
Falls between 3.60 and 3.61. Again, another measurable property that helps lock down the identification. All these numbers, while maybe a bit abstract, are like its unique ID card.
A very detailed ID card. Now let's talk about the elephant in the room, or maybe the tiny, almost invisible gem in the room. Its rarity.
Yeah, this is where it gets really mind-blowing. The Wikipedia source is clear. It's extremely rare. Still, even today, one of the absolute rarest gemstone minerals known, period.
So rare that its only real use is as a gemstone, right? No industrial applications hiding anywhere.
None mentioned, and highly unlikely given the scarcity. You just wouldn't use something this rare for anything else.
Where does it actually form? What kind of rocks?
It's typically found in carbonate rocks, often alongside minerals you might have heard of, like fluorite, mica, spinel, ironically, and tourmaline.
That association gives geologists clues about the conditions needed for it to form, I suppose.
Definitely. And while the first one popped up unexpectedly from a jeweler in Dublin,
Likely originating from Sri Lanka or somewhere similar, maybe?
that's where most finds occur now. The main sources are those alluvial deposits, the river gravels in Sri Lanka, and also southern Tanzania.
So people are still finding it, just
Yeah.
not very often.
Not often at all. The page also mentions some lower-grade taffeiite found in limestone sediments over in China.
Ah, so it's not just those two spots, but they are the main ones.
Seems to be the case. Wider distribution than originally thought, but still incredibly limited.
And how does it fit into the bigger picture of minerals, classification-wise?
Anderson and the team who first studied it placed it as sort of an intermediate mineral. Structurally and chemically, it sits somewhere between spinel and another gemstone, chrysoberyl.
Okay, so it connects to some more familiar gem families.
Helps to place it, yeah. And interestingly, the See Also section on the page mentions muscovite,
Muscovite. Don't know that one.
another extremely rare beryllium-containing gem, often confused with taffeiite, apparently. Maybe a topic for another day.
Ooh, definitely sounds like it. Okay, so let's wrap this up. What are the big takeaways from our Taaffeite deep dive?
Well, first, the absolutely unique discovery story found after being cut mistaken for spinel. That's unforgettable.
Yeah, the accidental detective work by Richard Taffeiite.
Then there's its unique chemistry, the first mineral combining beryllium and magnesium as essential bits.
Plus, its specific optical properties like that crucial double refraction.
And overriding everything, its extreme rarity, making it one of the most coveted gems for serious collectors.
It really is just bonkers that a finished gem held the key to a whole new mineral species.
Yeah.
It completely flips the usual script of finding a rough rock first.
It really does. And, it leaves you with a fascinating thought to chew on.
What's that?
If Taffeite hid in plain sight for so long, just because it looked like something familiar, how many other things, not just minerals, but maybe ideas or phenomena in science or even art, might be right under our noses, misidentified or just overlooked, waiting for someone with a keen eye, like Taffy, to see them for what they truly are?